Welcome to The Explainer. Today, we are going to completely change the way you think about a word you probably hear all the time, modeling. Now, when most of us hear that word, we immediately think of something pretty dry, right? Like a technical task, maybe a massive financial spreadsheet, or even one of those tiny plastic airplanes you glue together. But the truth is actually far more profound. As we'll see in the source material today, modeling isn't just a task. It's the universal cognitive engine of human thought. It is literally the invisible architecture behind how you perceive, how you organize, and how you interact with reality itself. So here is our roadmap for today. We're going to cover the cognitive power of modeling, subject, object, and medium, the IOMEMI modeling process, the upward spiral of feedback, modeling complex human behavior, and we'll wrap things up with the paradox of imperfect models. Okay, let's just dive right into this with a really fundamental question. What exactly is a model? I want to challenge your basic assumptions here for a second. We need to totally shift away from the idea that a model is just a physical miniature of something or a complex math formula. The sources suggest that a model is actually an event. Think of it as a highly concentrated manifestation of how you, as a human subject, experience and process the world around you. To really get this, look at the stark contrast between these two paradigms. The old way of thinking basically assumes that a model's only job is to be a Xerox copy of reality, just reflecting things as accurately as possible. But the new paradigm, which is heavily influenced by the philosopher Gilles Deleuze, argues something entirely different. It argues that modeling is actually about creating meaning. It's about forging new relationships and generating differences. A genuinely good model doesn't just sit there and passively reflect the world. It creatively reorganizes it, essentially pulling your thoughts right out of their normal everyday routines. Let's kick things off with Section 1, the cognitive power of modeling. This is, without a doubt, the brain's ultimate superpower. You see, the creation of a model doesn't start on a whiteboard or a piece of paper. It actually starts right inside your nervous system. According to neuroscientists like Joseph Ledoux and Jeff Hawkins, your brain is constantly receiving this flood of raw sensory data. But here's the thing, that data all by itself, it's completely meaningless. Your brain has to actively combine those senses with your past memories. And the absolutely crucial ingredient here, emotion. Emotion isn't just some random byproduct. It is the core driver that decides exactly what gets remembered and how we categorize it. So logic and feeling are deeply intertwined to generate what we call a mental image. And that mental image is the foundational raw material of any model you ever create. And we can actually watch this cognitive capability evolve just by looking back through art history. It's fascinating to see how human cognition shifted over the centuries. Think about prehistoric cave paintings. That was all about copying raw sensory input just for basic survival. But then jump to the medieval era, and the focus shifted completely to modeling invisible spiritual hierarchies. Then the Renaissance comes along and brings us geometric perspective. Fast forward to Impressionism, where artists are suddenly modeling the fleeting perception of light itself. And finally, you get to abstract art, which basically stopped trying to model the external world altogether and chose instead to model our deep inner relationships. So really, art history is basically a timeline of human modeling, evolving from basic replication to complex internal generation. Moving right along to Section 2, subject, object, and medium. We like to call this the Trinity of modeling. To really understand this trinity, we have to make a clear distinction between our internal and external languages. Your internal language is that deep cognitive structure inside your brain, the one that organizes all those messy sensory inputs into neat concepts like danger or chair. But if you want to actually share that model with someone else, you need an external language. You need a medium. That could be spoken words, a mathematical equation, or just a quick sketch. But here is the truly fascinating part. That medium, it is never neutral. When you write a thought down on paper or you code it into a software program, that external medium actually acts back upon your internal language and fundamentally transforms your original thought. You are quite literally reshaping your own mind through the medium you choose to use. So how do we actually do this? That brings us to Section 3, the IOMEP modeling process, where we ground all this high-level philosophy into everyday practice. The IOMEP framework is fantastic because it breaks modeling down into 7 incredibly fluid steps. First, you have intentioning, then observation, mental image making, expressing, prototyping, implementing, and finally adjusting. Now, setting that initial intention is absolutely crucial here. If your intention is fuzzy right out of the gate, your observation is going to be scattered, and honestly, your final model will probably be useless. Pinning down the specific question you were trying to answer dictates the success of every single step that follows. It's the anchor for the whole process. Let's actually zoom in on that fourth step, expressing, to see how this builds on what we just talked about with mediums. In this step, you're making a two-part decision. First, you have to select the language mode. Are you going to use text, visuals, or math? Then you select the medium. Is this going on paper, into code, or maybe a 3D physical space? Combining a specific language mode with a specific medium acts just like a dynamic lens. Think about it. If you describe a complex system using only text, you get crystal clear logic, but you completely lose the spatial relationships. If you use only a diagram, you see the structure perfectly, but you might lose the nuanced logic behind it. The absolute best modelers know how to creatively combine these to alter and enhance the reality of the final output. All right, section 4, the upward spiral of feedback. Because in modeling, it's always about iteration over perfection. You have to realize that modeling is never just a one-and-done event. It is a living, iterative, upward spiral of constant feedback and adjustment. And this principle applies universally. In science, theories are modeled and then rigorously tested against nature. In engineering, prototypes are built specifically to be broken. In education, curriculums are constantly adjusted based on student feedback. Whether we're talking about Karl Popper's famous theories on the growth of objective knowledge, or, just trying to manage your daily calendar, which we all know rarely survives past 9 a.m. anyway, this spiral affects everything. You take an imperfect model, you apply it, you learn from the failure, and you adjust. It's a universal loop. Which leads us to the trickiest part. Section 5. Modeling complex human behavior. This is truly the ultimate challenge. So, when experts try to capture our bounded rationality and our incredibly unpredictable nature at scale, they generally use two approaches. On one hand, we have what's called lumped systems. This is basically treating a massive crowd as a single, predictable, statistical flow, kind of like modeling the flow of highway traffic. But on the other hand, you have the more modern approach, distributed systems, specifically agent-based modeling. In this approach, you give individual agents very simple rules, like a single ant following a pheromone trail, and then you just sit back and watch as highly complex, totally unpredictable crowd dynamics emerge. It beautifully proves that the whole of human behavior is vastly, vastly different from the sum of its individual parts. And when we zoom all the way in on the individual human, we run straight into the problem of subjective perception. A physical thermometer might tell you a room is exactly 21.3 degrees Celsius, but a human will just walk in and complain that it's a bit cold. So how on earth do you model that kind of subjectivity? Well, the brilliant mathematical solution highlighted in our sources is Lotfi-Zadeh's fuzzy logic. Instead of demanding rigid, binary numbers, fuzzy logic actually allows computers and models to process messy, subjective, linguistic variables. It effectively builds a bridge right between rigid mathematics and the soft, squishy reality of human perception. And now, our final stop, Section 6, the paradox of imperfect models. Let's talk about why we actually need to embrace the flaws. Whenever we build a framework to understand the world, naturally we want it to be perfect, right? We want it to explain absolutely everything with zero contradictions. But back in 1931, mathematician Kurt Gödel completely shattered that dream with his shocking incompleteness theorem. Translated into the world of modeling, this theorem mathematically proves that no model, no matter how ridiculously advanced it is, can be both completely comprehensive and perfectly consistent at the same time. If your model tries to include every single tiny variable in reality, it will eventually contradict itself, period. But if you force it to be perfectly logical and consistent, it's inevitably going to leave out parts of reality. Every single model has a blind spot. It is just an inescapable paradox. So what do we actually do when our models inevitably break down, or worse, trap us in one of those blind spots? We turn to a really profound concept from the scholar Douglas Hofstadter. He calls it jumping out of the system. Think of it like this. A person trapped inside a maze cannot possibly see the exit until they elevate their perspective. In the same way, a modeler cannot fix a broken model using the exact same rules of that broken model. You have to engage in what's called meta-modeling. You literally have to step completely outside your own cognitive frameworks, view your current worldview as just one imperfect lens among many, and consciously choose to update it. Honestly, understanding that your entire worldview is just an imperfect model is incredibly liberating, because it means you are never, ever truly stuck. So, as we wrap up this explainer, I want to leave you with this question to chew on. What invisible models are currently shaping your decisions, your biases, and your daily life? And maybe more importantly, is it time for you to jump out of their system and build a brand new one? Keep questioning those lenses, keep learning, and thanks so much for exploring the cognitive engine with us today.